Hello, good morning, or good evening. Actually, it's nighttime. Anyway, good morning for you. Um, you get a 2 hour delay. How exciting. Anyway, you have a challenge today. You have to figure out the probability of getting hit by a falling Chinese satellite. Yeah, seriously. Uh, some years ago, a Chinese satellite was falling to the Earth. Normally, they save enough fuel in the satellite so that they can control it and it will fall into the middle of the Pacific in what they call the satellite graveyard so that it's hundreds and hundreds of miles from any human settlement. Something happened. They didn't know where it was going to land. So then everybody's wondering, oh, the sky is falling. It's Chicken Little. Um, what made it even worse is this happened on April Fool's Day. I'm serious. It wasn't a joke, but it's supposed to fall to Earth sometime on April Fool's Day. So here's the question. What's the probability of getting hit by a falling satellite? And you're going to figure it out today. You're going to get into teams. The teams are going to be one boy and up to two girls. The boys get to choose the first girl, and then once everyone's been chosen, if there's still some girls left over, guys, you can choose an additional one. Although ask your lady which one they want to bring with them. Anyway, here's how it's going to work. As most of you know, probability is the desired outcome divided by the total outcome. So if I'm rolling a regular six-sided die, the probability of rolling a 1 or 2 would be, well, desired outcomes are 1 or the 2 out of 1 through 6. So it's going to be 2 out of 6 or 1/3 probability. Most of you know that is also 33.3% repeating. Okay, basic probability. Now, geometric probability follows the same basic idea. Geometric probability is the desired area out of the total area. It can also work for volume, but we're just going to stick with area this time. So what's the probability of randomly choosing a point in the shaded area? Okay, if we have to choose some point in here, what's probability of randomly choosing a point right in here? Okay. To do this, we're going to find the probability of the shaded area, the green area, divided by the total area. Well, we got 2 by 3 over there, 3 by 8 for the total area, so 6 out of 24, which is 25%. So how does this apply to a falling satellite? You need to you can look up the radius of the Earth, but I don't want you looking up the surface area of the Earth. Use the handout that the substitute is going to give you, and I want you to find the probability of being in the path of the falling satellite. Okay? Now, that's not even saying you're going to be hit by it, but what's the probability of even just being in the area of the falling satellite? Once you've got that, then if you want to try to improve your prediction, you can. You can look up some other things if you want to. Okay? But basically, the satellite's going to fall somewhere in that little black area right there. What's the probability it's going to land? What's the probability that you're going to be in that area? Okay? Or in other words, what's the probability of some human randomly being in that area? Okay? All right. Then I'm going to want you to think, is this a good prediction? Is this or do you think the odds are higher or lower? And give some reasons for it. All right? Can you make your prediction even better somehow? You can look some other facts up if you want to, okay? But I want you to first find the probability that you're somewhere in the path, and then I want you to try to find the probability of actually what you think is getting hit by a falling piece of satellite. All right? That's your task. Make sure you show your work. And I want it shown in neat mathematical writing. First time through, though, remember, just barf down the information. Then after you think you've got it, go back and clean it up and make it nice, neat mathematical writing. I should see you tomorrow. Good luck. Bye.